The purpose of this exercise is to select 15 clusters proportional to population size. The data are from the official sampling frame for the tuberculosis prevalence survey in Tanzania. In the sheet, you see 125 districts listed in column A with their names, together with their population size listed in column C. For this exercise, we do not use column B. The first step is to sort this list in a random order to make sure that there is no hidden order in the list that might influence the selection of clusters. To do this, you need to give each district a random number. Go to an empty column and select the cell for the first district. Use the random number formula in Excel. This differs by language setting for your Excel, as I have explained in the lecture notes. My language in Excel is English, and I have to use the formula rand between. For every formula that you implement in Excel, you start with an equal sign, then the name of the formula, which in my case is rand between. Between the brackets, I give the range from which random numbers should be drawn. This actual range is irrelevant since the random numbers itself are not informative. It is also not a problem if there are duplicates in the random numbers. I just need them for sorting. So I decided to use a range from 1 to 100. I close with a bracket, I press enter, and I get the random number 64. I then copy this formula by dragging it down to all my 125 districts like this. You then see that each cell now has a random number, of which some might be duplicates. But you also see that the first cell has now changed to 44. Because with each action in Excel, like using an enter or performing a copy, a random number formula is implemented afresh, leading to a new number. This is not a problem, as said the numbers itself are irrelevant. When having the numbers, I need to sort on the data with the random numbers. For this, select all data by using Ctrl A in Windows or Command A when using a Mac. Go to the Data tab, then the Sort button, and select the column in which your random numbers are stored. In my case, that is column D. I can select to sort on smallest to largest or from largest to smallest. It doesn't matter. I just need a sort. Click OK, and now your list of districts has been sorted on the random number. It doesn't look like, because column D is not really in a smallest to largest order, but as said before, I have implemented a new command in Excel, so my random numbers have changed. Don't worry, this list has been changes on the initial random numbers, so I can proceed. I don't need the random numbers anymore, so I select column D and delete all the information. The next step is to create the cumulative population size as I move from the first listed district to the last. For the first districts, the cumulative population size is just the size of the district. Equal sign to indicate the formula. I select the district population size and I click enter, and I just have a copy of these numbers. Let us label this appropriately: cumulative population size. For the second district, the cumulative population size is the previous population size plus the population size of the current cluster. So equal sign, the previous cumulative population plus the current population size. So this 276,000 is derived by adding the previous cumulative population size with the current district population size. And this formula I need to repeat again and again. So I drag down the formula to all my districts in which way it copies. If you see these hashtags, it means that there is not enough space in your column to display the result, so you just have to scale a bit column D. And you see now that the cumulative population size increases with each addition of a district, all the way until the end. To see the formula behind the data, you can actually double click on it. So if I double click on here, I see which cells are used in the formula. And I can check that it is the previous cumulative population plus the current district population. So we are okay with this. Always good to make a little check. The cumulative population of the last listed district should be the same as the addition of all separate districts. And you can check this by actually adding all the district population size. And for this, you can easily use the AutoSum formula, which you can find on the Home tab under the sigma sign called AutoSum. And if I click on it, I just have to check that Excel automatically selected all my districts. Sometimes that goes wrong. And then if I click enter, Excel has added all these individual district populations together, and these two numbers should be the same. The cumulative frequency approach should give the same total as the addition of the district populations. And in this case, it's true, so we did not make a mistake. The next step is to calculate the sampling interval. The sampling interval is the size of the steps we are going to use to move through the list of districts to select our clusters. In this exercise, you are asked to select 15 clusters. And the sampling interval is the total population divided by that number of clusters. So I'm going to create a sampling interval, and I do that here, and you will find later out why, because it makes my life easier in the next step. I have a formula, so I start with an equal sign. The total population, I don't have to type the number, I can just select the cell, divide it by 15. And here you see divided by 15. In this bar, you can always see what formula you are creating. I click enter, and I see here a very large number. The problem with this number that there are no separated for thousands. So what I can quickly do is select column G. I go to the format buttons. I go to more number formats. I go to number, and I use this, tick this little box, use 1000 separators. And if I click OK, then at least I can read this number much easier. So my sampling interval is 2,831,515.53. It doesn't matter that it is a very funny number with decimals. The only thing that is lacking is a starting point from where we use these steps to go through the list of districts. The starting point, which I'm going to create here, is somewhere between 1 and the sampling interval, 1 and size of the steps. You can pick that number yourself, but it's always better to use a random approach. So again, I use the same random number formula in Excel, which is rand between, just as we had before. I start with 1 for the first person living in Tanzania, and now I select the sampling interval. Again, I do not have to type it. I can just select the cell, finish the formula with a bracket, and click enter. So my starting point for selecting the clusters is individual 737,182. If we see clearly, this number that we have now there is the result of a formula. And as said before, if you implement another step in Excel, a random number will change. And I want to actually record the proper starting number. So for that, I do a little trick. I go next to it. I select this cell. I go to edit. I copy. I go to the cell next. I go to edit again, and I'm going to paste special. Not to paste, but to paste special. And there I have the possibility to just copy the value without the formula behind it. I click enter, you see my same number, 737,000. And if I would make it again, you would see that my random number again has changed as expected. I don't need it anymore. Delete. So this is my starting number. I could do the same to make it more readable. I go to the formatting site, more number formats, number 1000 separator. I can now read it much easier. So the first cluster is that district that has this starting number in its cumulative frequency. So from the cumulative population, cumulative frequency, I need to look where number 737,000 falls. And that will be in this district. The cumulative frequency in Rombo is 550,000, which is too small, and the 737,000 number falls in this cumulative frequency. So we just have selected our very first cluster, Morogoro Urban. The second cluster is then nothing more than adding my sampling interval to my previous number. So it is adding the sampling interval to my previous number. So my second cluster falls in the cumulative population that holds the number 3,568,000. So I go to 3,468,000, that is too small, and the next one is 3,721,000, and indeed that holds the number 3,568,000. So my second cluster is here. And the third cluster is nothing else. It is adding the sampling interval, this one, to my previous number. And now you also see why it is clever to put the sampling interval a little bit up. You can easily select it. So my third cluster is that district that holds in its cumulative population the number 6,400,000, and there I go, that will be here. And all the other clusters are, of course, exactly the same. You must be able to select 15 clusters before you run out of data in your list. If that is not possible, you either have made a mistake in the cumulative frequency, the cumulative population, or you calculated the sampling interval wrong, or you added the sampling interval to the wrong number. So check these 3 steps if you are not able to select 15 clusters. I hope this was useful and good luck.